The Story of Everything, Chapter 7, The First 10 Seconds, the Lepton Epoch. We have reached the second in the story of everything, Sophia continued. We are in the Lepton Epoch, which lasted 10 seconds. Well, 9 if you subtract the Hadron Epoch. The diameter of the universe will reach 29 light years by the end of this epoch. This would make an orb around the Earth big enough to encompass the 55 closest stars, including Sirius, the brightest star in the night sky. But the disk of the Milky Way is 5,000 light years thick and 100,000 light years wide. So you'd still have a hard time finding an orb this size if you were flying through the Milky Way. That means the universe is still incredibly hot and dense because, as we must always remember, not just the whole Milky Way is stuffed in here, but also the few trillion other galaxies in the universe with their billions of stars. The temperature in these 10 seconds will drop to 1 billion degrees, far hotter than the 16 million Kelvin in the center of the sun. Meanwhile, the density will fall from that of thick sludge to a muggy day in Florida. That's not so bad, I said, eager to stretch my arms out again. As I said previously, Mother, the universe was getting simpler and more complex. More complex because structures in the form of baryons now existed. Simpler because nature was changing unnecessary particles into either necessary particles or light. This simplification continued during the Lepton Epoch. At the beginning of this epoch, there were still way too many electrons for people and books to exist, about 10 billion times too many, and there were an equal number of the antimatter counterparts of the electrons, the positrons. These leptons and antileptons still existed in abundance, hence the name Lepton Epoch, because the energy had still been high enough at the first second to continue making these leptons out of colliding photons. But as these 10 seconds progressed, the electrons and positrons annihilated, and to the everlasting joy of all creatures, 2 or 3 electrons remained after every 10 billion annihilations, just like with the quarks. By the end of the Lepton Epoch, all the positrons were gone, and there were exactly 10 to the 80 electrons to keep the 10 to the 80 quarks company, thus giving the universe a net charge of exactly 0. Meanwhile, at about 1 second, the other type of leptons, the antisocial neutrinos and antineutrinos, stopped bashing into everything and instead started flying through everything without interacting at all, as if they were ghost particles, and so they remain to this day. They were nearly as abundant as the photons when they decoupled from everything else, about 70% of the total photon count, in fact. And these primordial Big Bang neutrinos and antineutrinos are still with us in the 21st century, zipping through human bodies by the billions per second. Neutrinos are so antisocial that they apparently don't even bother annihilating with their anti-partners. By the end of the Lepton Epoch, the content of the universe was fixed in its final form, except for the ratio of protons to neutrons. Protons and neutrons were changing into each other due to weak force reactions from high energy collisions with the electrons and neutrinos. But the protons were winning because neutrons are slightly heavier, and so it requires more oomph from the weak force and from particle collisions to change a proton into a neutron rather than the other way around. So this interconversion process rapidly began to favor protons. By about 3 seconds, the proton-neutron interconversion slowed to a halt. No more new neutrons. At 10 seconds, there were about 5 times more protons than neutrons. This had me worried. These 1 in 5 neutrons needed to quickly find a way to outlive their 10-minute average lifespan, or we'd have a hydrogen universe for all eternity. The recipe is done, Sophia announced. All the ingredients have been perfectly measured out. It is time for the universe to bake. We are about to enter the Big Bang nucleosynthesis epoch. And because the main part of it lasted about 6 minutes, I will finally show you the story in real time rather than the ultra slow motion we've been doing. Wait, I interrupted. Before we move on, I have a special request. Whatever you wish, Sophia replied. I said, let's restart the Big Bang from scratch and let it play out in real time so I can see what it was like if we were there, normal body size, not slow-mo, and the Big Bang erupted from the center of my brain. That sounds excellent, Sophia said with delight. Let's do that. Everything rewound, and it was dark and suffocatingly silent again. Ready? Sophia asked. Ready. Okay. 5, 4, 3, 2, I fell unconscious. 1.